All right, we're right on time. I see Brad, Yogesh. We'll give a few more minutes for folks to join. Yogesh, do you know if Dimitri's joining?
Yeah, I just pinged him. Let's see.
Okay. Oh, there's Eric. Okay. All right, a couple more minutes. We'll let Dimitri join and then we can get started. Few minutes pass. We'll get started. We'll let folks come in. All right, welcome everybody to Tigress interim meeting. Thank you everyone for joining us today. I unfortunately Leaf could not make it. I don't know if he's planning to join a little late, but we'll get started. And so first thing first, please note the note well. We want it to be a respectable conversation. Please listen to everybody's ideas, and this is more like a brainstorming session and coming up with better solution for the problem we are trying to solve. So let's be respectable of everybody and make sure we are following IETF processes and protocols. Um, Meeting tips, if this is mostly for in-person, so we'll probably just let it pass. I posted the document link, the two documents that we have right now, proposals in the chat. If you have not read them yet, uh, take your time, read it. I'll quickly go over the agenda and then I'll hand it over to Brad and Ecker. I think, first of all, I want to thank everybody who sent their feedback on the mailing list, Aaron, Alan, and a lot of other folks who went and read the requirements draft, the threat model, and then solution draft. So thank you very much for that. And then since ITF 117, we have actually gone through quite a bit, like in terms of how we want to proceed. And we actually have two proposals now. One is the original proposal by Dimitri and Yogesh, and then the other one that Eric and Brad came up with. So the idea for today's meeting is that we will go over the new proposal, we'll go over the changes and update made to the existing proposal, and then we'll just open the floor for questions. We don't want to run any consensus check today, like which way the working group is leaning. That is something we plan to do maybe a little before 118 or at 118, but today it's more about discussing both the proposals and asking all questions or anything that working group members have found out during their review period. So with that, I will hand it over to Eric and Brad. And I will go ahead and stop share. Actually, I'll share a different screen. All right, let's see. Can everybody see it?
I can.
Okay, perfect. Eric, my apologies. I had a little bit of struggle getting the slides into meeting material. Somehow they're not showing up. So I'm just sharing my screen. I hope that works.
Yeah, it goes kind of a mess, unfortunately. Great, thank you. So I think the backstory here, right, is in the previous meeting, I sort of made the observation of the microphone that I thought you could do this without having to do a bunch of API mechanics using basically existing HTTP stuff. And so subsequently, I sent an email list describing what I thought you could do, and then posted this draft that Brad and I worked on. Can you go to the next slide, please? So the basic idea here, so I think that, this proposal has the same, I think, if you just ignore what's in the arrows, has the same basic arrow mechanics as what we've been talking about, using web server as a Dropbox. But the question is what goes on the arrows, in particular, what are the messages actually being sent? And so the basic idea is, instead of using something that is like functionally like a web API or an RPC mechanism, to use something that basically is functional using HTTP with a standard HTTP verbs, which is to say put, get, and delete. I think some people might call this REST. I'm not going to fight about whether it's REST or not. Instead of having the server do access control enforcement via sort of internal new mechanisms, to have the access control enforcement be by concealing the address on the server of the resource. So that means that if you don't know the address of the resource, you can't read it, and you also cannot write it. Just conceptually, obviously, you could write any resource you want, but the resources will have long enough addresses that you will not be able to predict the resource address. This is a fairly standard, technique, obviously, often called capability URLs. We're not doing it quite the way that, say, Google Docs does, but not too dissimilarly. So can I have the next slide? And let me turn off what just made that happen. So I think I called this setup phase. So basically, at the beginning of the transaction, Alice generates a random. So we'll call that basically the underlying assumption is that Alice and Bob get like one free message that is relatively short. I think it's and then everything else has to be done through the server. So that's the same mechanics we've been discussing all along. So at the beginning of the transaction, Alice generates a random message that she sends to Bob. It's got like much the same thing we talked about here, which is to say it has like the address of the server. And the only thing that's really different is it has this random string R, which is like something that's reasonably high entropy. We'll say 128, 256 bits, something like that. So she sends it to Bob, and then she then post and so I'm assuming that we're looking at that fundamentally Alice speaks first in the transaction, namely that that Alice first sends the initiating message for coordination, but then the larger protocol message also she speaks first. Obviously, Bob could speak first. You could reorient this. But in any case, the person that speaks first takes the first message and shoves it in the server in a location which I'm calling L0, which is defined as a deterministic function of R. So in your head, you should think hash of R. It's actually HKDF of R with some diversity, but fundamentally it's a hash of R. And the only thing secret here is R. So anybody who knows R can read this message, but for the moment, I think we should just assume that only Bob knows R. We can talk about the security analysis a little bit. Bob's able to compute L0 by taking the same heuristic function R, and can read the message. And as soon as Bob read the message, Bob deletes the message. So again, these are all standard HTTP verbs. I do want to sort of emphasize that there's been a lot of back and forth about what it means to actually read the message. You do actually need an explicit acknowledgement from Bob that he's read it. However that's done, in this case, it's done by delete, because otherwise you have the possibility that Bob retrieves the message from Alice's perspective, there's some network outage or network failure, and so Alice thinks she's transmitting the message to Bob, but Alice is not. Sorry, the third server thinks transmitting the message to Bob, and Bob is not. So Bob does the get, and then Bob loses his Wi-Fi and doesn't get the data, and there's no way for the server to detect this operation basically at the network level. And so you actually do an explicit acknowledgement in any protocol for correctness. So delete in this case serves that purpose. Bob's response message is a new location L1. Which again is a deterministic function in this case of both R and Alice's first message. Since Alice knows her first message, she can reconstruct L1. She does the same thing. She does a get followed by a delete. And the handshake continues in this fashion, where basically every location is a deterministic function of the previous locations. Can I next slide? So as I keep saying, these are standard HTTP verbs, put, get, and delete. So if you have a server which allows put, get, and delete, this will simply work. The only requirement from the server that is even remotely unusual is a server not allow enumeration of resources. So what I mean by that is that these resources are named, and I think we have a template later on, but these resources are named something 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 /R or L0, and obviously if I were able to enumerate the resources that start with something something something, then I can just read all things. But this is a very standard HTTP configuration. If you go to basically any web server, like you go to like google.com and you put in google.com/, it doesn't let you enumerate all the things under /, right? So this is a standard configuration. It's just a matter of you have to configure your server this way. Next slide. So as I said, all the security in this mechanism is provided by the secrecy of the URLs. The initial message from the server has this random value R, and URL 0, which I called L0 in the previous slide, is derived from R. So only Alice and Bob, if only Alice and Bob know R, then only Alice and Bob can retrieve the first message. The subsequent messages each include random nonces, and URL m+1 is derived from the transcript of all the previous messages. So the consequence of this is that that if you know R, but you don't see message 1 or message 0, I guess, then you won't be able to see where message 1 goes. And so you have to see all previous messages in order to know where anything is going to go. So this means both for reading and for writing. So similarly, if you don't know R and you don't know message 0, then you can write you can write in some random location, but you can't write where Alice is expecting message 1 to appear. The messages are also encrypted with keys derived in the same fashion. This is the encryption. I think I did some slightly different encryption from what's in the other draft, but conceptually, there's similar concepts. I just was using HKDF already, so I already had some mechanics. So I think it's pretty clear at this point that if R is secret, then the attacker cannot see any messages in this exchange and cannot insert messages in the exchange. Tommy.
Hello, is that working? Cool.
Yes.
So just a clarifying question here. So I like that they're based off of each other. Let's say one of Alice or Bob.
Yeah. Yeah, I didn't do anything about that, but I think that's the answer to the question. Is it ought to garbage collect at a certain time? Yeah. No, it's not in the draft.
Aaron?
Yeah, hi. Can I just ask a clarifying question on this too? I'm assuming, if I'm understanding this correctly, I'm assuming that this exchange and the n+1 messages are intended to happen within a very short window. It's basically the back and forth exchange to complete the credential exchange, and then that is complete. So you're not expecting these to last more than, I don't know, a couple seconds.
So I think the answer is largely yes, but my understanding of the design space is that it's certainly possible that that people won't be online at the same time. in which case this will take like rather longer. But as a practical matter, I don't see how
Okay.
this really works. If this takes place over a couple of days, then I don't see how this like really is a functional system, regardless of like, regardless of like what the security properties are.
Okay, but they're in either case, they're not intended to outlast the particular handoff of the credential.
Correct.
That's right. Yeah.
Okay. Thanks.
David.
Is it possible for a denial of service attack if one knows the format of the URLs?
I think, well, perhaps, I think there are two denial of service attacks I might be interested in. One is denial of service attack on the exchange, which I think is the more interesting one. That is denial of service attack on the server. Denial of service attack on the exchange, no, I don't believe so, because the things are high entropy, so you can store crap on the server, but it won't be the places that people expect it. I think I didn't think too much about the denial of service attack on the server in terms of injecting, just like storing random stuff. I think that probably is, as we saw, with separate set of mechanisms.
Are you saying that there's enough entropy that it's unlikely that you would collide with the?
Correct. Okay, great. So hopefully I think I persuaded you that that if R is secret, then this is fine. There's a bunch of discussion on the list, I think, about cases where R was subsequently revealed. So I think if you can go to the next slide. Right. My assertion, and I don't have like a proof, but I think we can generate one, is that first of all, as I said, if you can't read the if you don't know R, then you can't read the first message. But say R is subsequently disclosed. At this point, there's basically my claim is that if R is known, but the first message, I say message 0, is deleted by the receiver, then the attacker can't see the address for the second. So at this point, the receiver already has the message, so he's not trying to read it. And the attacker can't derive location 1 because it doesn't know because it doesn't know what the contents of message 0 were. And so even if it manages to extract R, it still can't generate the correct sequence of locations, and so can either send or receive messages. So just to state this again, an attacker who learns R after the receiver has received and deleted message 0 cannot participate in the exchange in any way. Now, obviously, there's a race condition here in the sense that an attacker who learns R at the same time as the receiver learns R, because like it's posted on the internet or something, then the attacker can do the same thing as the receiver can, which is to say read the messages and delete them, and then they become the receiver effectively. This is like inherent in the design setup of the system. The only way to remove this problem is to create a new share secret, which isn't known by the attacker. So I think we can get into this later, but like my position is we have to simply assume that that the initial channel is secure, and that if R is disclosed at some substantially later date, because otherwise we need like a new mechanism like that is outside that channel. So I mean, the bottom line is that if you want distinguishing the attacker and the legitimate receiver, the legitimate receiver must know something the attacker does not, and that means they must have a secure channel of some kind. I think the easiest thing to do is simply assume the channel we have is secure, but if not, we'll have to construct yet another secure channel. That's not out of concept. I mean, so like as a hypothetical, you might imagine saying that the way this is supposed to work is that I send you like an SMS, and I also tell you, look, your secret is like 1, 2, 3, 4, 5, 6. That has to be short because it has to be like communicated verbally as opposed to in text. Because if we just assume text is fine, then we're back to where we started. Then we need a substantially different protocol from anything I've seen designed here, because we need to know the fact that secret will be very low entropy. So I say there is a race condition here, but it's like not removable by any mechanism I know. Next slide, please. Notice that this does not provide any form of notification at all, so you have to poll. Obviously, we can have notification, but this requires like some API surfaces that want notification, and from there on, you say you do something like web push. This is like I think orthogonal the design of the rest of the system. So I think probably should be delivered separately. But I just want to flag that as a deficiency of this design as it currently is. And I think you just want to staple it on via known mechanisms. Next slide. So I think there was some concern, as I sort of mentioned earlier, about like this sort of that use of secrecy only as a way of protecting the exchange. And so it's worth noting that you can add an additional mechanism as a certain bonus to better system that doesn't depend on deletion. So I think perhaps some of the concern was about whether deletion would work properly or whether like receivers would actually delete. And so if you also don't want to be dependent on deletion, and just to be clear, if you don't delete and R becomes public, then of course the whole exchange can be recapped, right? Because deletion is what prevents the attacker from learning the secret in message 0 and subsequent messages. Brad is just an additional mechanism where you have the attacker sets cookies for each secret URL. And at that point, basically, once 2 cookies have been issued, then the URL is locked. And Brad, I think you maybe want to explain this more clearly than I'm going to. So I'm just going to actually.
So I think you captured that sufficiently. It's effectively you use session cookies and limit the exchange to participants' session cookies for a given R. The one thing I want to note is in your preamble to this, if let's say Bob is neglectful and doesn't do deletions properly, if Alice does, as long as you get to message 3, then you've restored the property that you can't replay even if you have R.
That's correct.
So this
Thank you.
is narrowly fixing the potential issue of Bob not deleting or an attacker getting in before the deletion before message 3 comes through.
Sure.
We have James in the queue.
The way the initial sequence looked like, it looked like Alice was not going to send the next message until Bob deleted anyway. So if Alice just blocks on the deletion, doesn't that also mitigate it?
I hadn't thought about that. That's an interesting suggestion. That diagram was not intended to indicate that was supposed to happen. I just drew the diagram in sequence. But I think that
Alice could
that's an
also
interesting suggestion.
when Bob puts.
Okay, so my next slide was like just questions, and we're taking questions all along. So I guess we're still taking questions, but there's no more material.
All right, thank you, Eric, Brad. Anybody has any more questions for Eric and Brad before we move on to the second proposal? Okay, I see Aaron joined the queue. Aaron, go ahead.
Is the second draft solving the same? Is it like an alternative to this proposal? If so, I'll wait until then for my comments.
It is. In fact, it's the original proposal by somebody else.
Okay. So I will take myself off the queue.
All right, Christopher.
Yeah, can you hear me? I think you can. I'm at an airport, so I apologize for the background noise or whatever. I quite like this design. The core of it is super simple, and you can compose it with lots of different HTTP-specific technologies to like increase the security. Like you might imagine, like running this with HTTP if you wanted sender privacy. You might imagine like plugging in some sort of, I guess, high-level layer of like encapsulation if you wanted secrecy of R and these initial values. The fact that this plugs nicely into lots of different deployment scenarios and lets you kind of tailor how you protect R to what makes sense for your application is really quite nice. So this is great. Thanks for putting it down on paper.
Thank you, Mr. Mitri.
Yeah, I think you're muted.
Can you hear me?
Yes.
Okay, awesome. I'd like to join Christopher. I really like this protocol. A couple of clarifying questions. So on slide 3, can we move there, please? Is there a mutual agreement between Alice and Bob before, like in advance, on the URL of the HTTP server here? So we're passing R.
Yes. So I think the underlying assumption, I think, was, at least from my side, was that Alice would provide effectively a URL template, and I can't remember the RC number for that, and then it would provide R separately. In principle, just to make it clear which thing was R and which thing was the template. But yeah, you provide a URL template.
And how does it resolve to the URL address? Is it like a single HTTP server?
Yeah, so URL, right? So URL template is basically a URL with some like indicators of where you put things. So like if you think about it, like you say URL template, and it would say, mumble, xtp://example.com. And then there's basically like, if you think about like string interpolation in Python, there's basically like a string interpolation thing, and it says stuff your secret here, right? And so we all agree on what the name of the secret was in the template, and then you just stuff it in. I can get. I don't have an example here, but it's but I can send one of the list.
Okay, and then the question. Second question. So the time delta between get and delete, what is it expected to be? The time of issuing. The difference.
I think I would think almost immediate. As soon as you have it, you should delete it.
But it obviously takes into account the time it takes for the request to be delivered from the device to the server, right?
No question. As I was indicating earlier, I think there's just sort of an inherent lag here, in the sense that that whatever. So whatever the technical mechanism, you want what you want is at most one semantics, then the server has to be prepared to accept a new receiver up until the point where it's certain that the data has been delivered to the receiver. And so that requires some message from the receiver to say, I actually got this. And if you think about the cookie technique that we've been talking about, unless you're very careful, what's going to happen is if the receiver issues the cookie, if the server issues the cookie, and then there's a network outage and the receiver doesn't get the cookie, but the receiver thinks it has, then basically you're deadlocked. You can't proceed. So yeah, I think there has to be, for correctness reasons, an explicit message from receiver to the server that says, "I got this."
Okay. And speaking of the cookie, so the first cookie from Alice is delivered to the server with the first request, right? With the put.
I think if you were to do the cookies, yes.
Okay, and the cookie from the Bob is delivered with the get L0?
Yeah.
And the cookie is delivered as a part of the HTTP request header. Properly.
Yeah. As I say, I'm not sure we need to do this, but if you were to do it, we do that on that way.
Okay. No more questions there. Thanks.
Thanks, Dimitri. Tommy.
All right, there we go. I keep having to wait for the audio to come on. So
I think we do need it. That's a chair question. How we cut it up. I thought it was useful to try to just specify the pieces that I thought were security confusing, as opposed to the pieces that I thought were that were not. But I think you do need to say what the content of the message. The content of the message has to be specified somehow, right? And it seemed like, I guess what I would say is, it seems like we ought to figure out what pieces are generic. And that everyone's going to want, and specify them. The pieces that are not generic, we should punt out to these you know, to the bindings. I mean, I'm happy to put that in the, I'd be happy to like, I'm happy to have that in this, I mean, like, if we decide this is the way to go, I'm happy to have that in this draft or some other draft, and I'm happy to like, you know, I will say, like, I do not understand those pieces very well. And so like, I think someone else would have to contribute some of those pieces. And, you know, again, like, you know, more than happy to have some collaboration on that if the chairs determine if you want draft.
All right. Thank you, Tommy. Eric, do you have anything to add?
Nope. Well, I guess all I'll say is like this draft of the list. It's a 0-0, so like, you know, quality is what you get. You know, if people we're happy to take PRs. And if people have questions, if they come out after this and you're like, well, this is stupid and it's broken, please like do like say something and we'll try to either fix it or admit it's broken.
One thing I'll add is there is an issue about a versioning mechanism.
Oh yes, thank you.
There are lots of versioning mechanisms out there. Lots of ways to skin this particular cat. Ecker and I have opinions, but if others have opinions, that would be a good place to voice them.
It occurs to me that, yeah, and I think that's actually a problem that if I recall correctly, all the previous proposals have had as well. So we probably need to think about that problem more generally on whatever we adopt.
Okay, perfect. Thank you. If there are no more questions for Eric, we can move on to Dimitri and Yogesh. They're going to share the updates made to the original solution. And I'm going to share your draft here. Oh, sorry, your slides. All right. Go for it, Yogesh.
Hi. Thanks for giving us a chance to present that original draft, which is slightly modified, I guess, for better readability. So I wanted, so based on the previous feedback that we needed to make sure that the terms are clearly clarified. So I'm just making that attempt here in the first slide that what do we mean by digital credential? It's that cryptographic material and other data that enables to access a property using a mobile device. And that other data can include a lot of things like what is the radio technology that you need to use when you present your mobile device, or other details as necessary based on that property type. And the second term that we talk about is called vertical, which essentially is a standards and bodies that cover different types of properties. And I think Aaron had a question on mailing list, like what is a property? So let's to define that. It could be a car, homes or hotels or anything else that can come in future. And there are standards and bodies that cover all these different verticals, as we say. Like there are standards for car digital credentials or home credentials and so on. Then we have defined this process of provisioning, where how do you get this credential on your device? That process is termed as provisioning. And provisioning information is all the necessary and sufficient data to get that credential on your device. Next slide, please. So the idea is that once we have a credential on our device, the next natural use case is to share it with someone. And as we have mentioned in the draft, some of the examples are that I have my car that needs to be moved for car cleaning from this side of the street to other, but I'm out of town. So I ask my neighbor over my favorite IM that, hey, can you please do it? And then send the next message on top of that same IM, and they get that credential and move it. or you're sharing your hotel credential with someone while you are in flight, so you may not be available at the same time. They may see the message after a few hours or maybe a day or so, and then they react to it, which is a very natural, typical use case that the recipient may not necessarily respond right away to the initiator's message. There could be a huge delay, and then the back and forth may not happen within few seconds. Maybe I send somebody while I'm hopping onto a flight, and then I only see or get connectivity back after I'm off the flight. So those are real situations that may happen. So when talking about sharing, we want to provide a convenient and seamless user experience. So this sharing notion should feel similar to sharing other digital assets that we are used to, like sharing photos or documents, like just drag something into an email, send it out, or a photo, or use other channels, I guess, to just drop it to someone. With that said, next slide, please. So the natural question is, how is this different from sharing those other digital assets, right? I mean, how about just dropping a photo or document? So one thing is that there are possible round trips required between that initiator and recipient without user interaction, so that user interaction happens only in the first step where you are initiating the share, and on the recipient side when you're accepting it. Everything else, all those round trips happen without user being involved. And also note that the users may not be online at the same time. So there could be a huge time gap between those interactions. Then the second unique requirement is that the first recipient device that claims this invitation should be the only device that gets the whole provisioning information. Third unique requirement is that invitation to share goes over existing communication methods that users prefer. And we do not assume security or privacy properties of that mechanism. It could go over something which is super secure, but it could go over something that is not. And I guess as more use cases show up, it could be even like transmitted in a public forum kind of a place. It's not that hard to imagine that. So we cannot assume security of that initial out-of-band message. And the last point is that the security and privacy of that provisioning information while in transit is necessary, even if the initial message is not secure. Looks like there are questions. Maybe we should address them.
Yeah. Aaron?
Yeah, I have a question about that. No security properties can be assumed about the communication method. So are you saying that it should be possible to securely transmit the credential starting with an insecure communication channel where you can assume that somebody may be able to observe it?
Yes. So idea is that, say, if I'm going to become generous and give my car away to whoever gets first and post it on some of those message boards, that should be possible. I'm
okay,
not that generous, but
that's different. But like if I intend to share it with one person, but send it over a channel that I can't assume isn't compromised, is that something you're worried about? Is that a use case you're worried about supporting?
Can you elaborate?
Yeah. So let's say that I know that my SMS messages are being copied by the carrier to somebody else, and I know that everybody can, my SMS is not a secure channel, but I send this first message over SMS to one person. Now, I can't know that my intended recipient is going to be the first one to claim the key. So is that something that is that an acceptable situation, or are you trying to protect against that kind of attack?
So that is an acceptable situation in the sense that we want to acknowledge that it is possible that when you share that SMS, it may not go to your intended recipient. But we don't want a situation where you think it did go to the intended recipient, but somebody else was able to actually monitor the entire conversation and glean that data. Because the verticals can enforce secondary factors if they deem that the initial communication method used was not secure enough. So it gives them a chance to put something on top. But the idea is that once that exchange is started, that is secure enough. Does
Are
that
you saying that the
answer?
verticals may define their own completely separate out-of-band mechanisms to protect the credentials? Is that what you're expecting?
Once it is issued, they could, because the idea is that we want to allow users to use whatever their favorite channel. We don't want to impose restrictions on that. But if they happen to use something which is super insecure because there are some known security attacks out there, then the credential may impose something that will a second factor, which would be out of scope of this because it's vertical specific, but they can impose that.
Okay, I think I see where. Yeah, go ahead.
So Aaron, we recognize the risk. We recognize that the channels used to deliver that unique identifier of the mailbox along with the URL may be insecure, but we address this by proposing a second, like a separate channel to deliver the secret, the encryption key, and a second factor at the time when the secret is credential is provisioned to the wallet. So 2 additional mechanisms.
So the point is that we don't want to assume that the first communication channel is secure at all. We want to design something which even works in case where it's not secure, yet the provisioning information is indeed delivered securely to whoever is the first to claim it.
Okay, I think
so. It's a piece, building a piece like a Lego piece, so that something else can be built on top of it.
Okay, in that case, I think this opens up a huge can of worms and a huge additional problem space that I don't think you can ignore. And I don't think that just targeting this first exchange is by itself is actually going to work in isolation and just assuming everything else will kind of happen. So I do think you're going to need to get deeper involved in some of the existing other places where those kinds of second factors or other protections exist to actually address them here.
So that
I think
does happen actually. Go ahead. Sorry.
Go ahead, Yogesh. I think the problem is the same as with the protocol presented by Ecker. The original R secret needs to be delivered from Alice to Bob. And there are some potential risks if the channel to deliver that secret is insecure. And we have the same problem here. What we propose and what we presented in the risk in the threat model is that in addition to that original URL, which contains the unique mailbox identifier, which is kind of similar to that R secret in Ecker's proposal, we ask users to deliver the encryption key out of band, like in a different channel, probably more secure channel.
No, okay. I get that. I'm talking about popping up like 2 levels of the stack and forget either proposal at the moment. I think you have to go back to a bit more fundamental design of what's going on here, if that is something that you actually are trying to design for. So, because both those proposals work analogously, you know, and they have that same problem of the first secret, and if you're starting with these, you're gonna end up having to the things you need to do to protect against what you're talking about. It may exist already in other groups or other communities, and I don't think you can start from this this place of this kind of design without and also ignore all of that stuff until later.
So the idea is that if we go and impose this restriction that the first channel has to be secure, right? I mean, that to me is a subset of the problem, because in reality, no matter how secure we claim a channel to be, it will be broken at some point, or there are attacks that do get discovered. So we are designing against the minimum possible security of the first channel, and then there are going to be second factors that the verticals will work on.
Sure, that's fine, but I don't think you can just ignore that until later and make it the burden of the verticals to solve. It needs to be addressed now. Like, it has to be part of the core design.
So the sorry, go ahead.
Yogesh, Aaron, I'm sorry to interrupt. In the interest of time, can we move this conversation to the mailing list? Yogesh, would you take it as an action item, like to go ahead and start a conversation on mailing list around it? And Aaron, if you can jump in and share your thoughts there. Does that
Sounds
work
good.
with everyone? Okay,
Fine.
all right, thank you so much. Were you saying something, Aaron? I'm sorry if I... Cool, all right, we'll move to Eric.
Yeah, so I'll let me make 3 points. The first is that like this discussion we're having now is the most important discussion to have, and like all the protocol design is downstream of this discussion. So I think actually like and you guys are absolutely right that like what I presented is designed under the assumption that that channel is secure, and if it's not under the channel and that the channel is insecure, then like bigger problems than like the attacker coming in late because the attacker just steals your car, which is like bad, right? And maybe I know the attacker stole my car, but that's like bad news, right? So I think it is critically important to like understand. So I think that's point 1. Point 2, I think is our job to solve the entire problem, not just a piece of the problem. And so if the underlying assumption is that we solve a problem in the face of an insecure channel, then I think pushing on the vertical is not appropriate use of the IETF's process, and that the IETF has to solve the entire problem. The third thing I would say is that they're precisely two, so everyone seems to assume that they're the discussion just a minute ago seemed to assume that there are 2 channels. One is this SMS type channel, which we don't trust, and there are some other channel which you do trust. So like I guess I don't quite understand how we get to the point where we have that like second channel, but it seems to me that second channel it can either have one of 2 properties. Property 1 is it is low entropy, in which case so property 1 is high entropy. In which case, if it's high entropy, then like I don't understand like why we can't treat that as like why you can't just use that for everything, and why we have to worry about the insecure channel. Property 2 is it is low entropy, in which case it is actually quite a challenging problem to design a protocol which has this like high entropy channel that is insecure and a low entropy channel which is secure. And you're like looking at PAKE or something like that, and that's like even more important for the IETF design that because people are definitely going to get that wrong. So I think like really fleshing out like exactly that if like. So I think it's just really important that we flesh out exactly what it is we think that like the use environment is here, and exactly what channels exist and don't exist, and then like we can argue about those channels whether we think that's an accurate model, and then once we've done that, then we can design a protocol that like matches up with those channels, with the situations. But like I will say I'm quite skeptical of like the scenarios being presented here, but like in any case, that's the thing we have to flesh
out. So a response would be that that low entropy channel between the users requires user interaction. So yes, the first thought would be to just have the entire exchange over that super secure, if that channel was super secure, but then that does need user interaction, which is not a possibility because in terms of the user experience, user is going to only take an action one time, and then everything else has to happen in the background. And that background is where this IETF channel that we are trying to talk about. I think that's the idea. So this notion of 2 channels exists because there is a user action that initiates and accepts the interaction, and then the interaction that gets handed off to this other channel.
But I guess I don't understand. I guess I understand what you're saying. So like I'm gonna like I want to share my car with Brad, and I'm gonna send Brad an SMS, and we all agree that, and so by stipulation that SMS is an insecure channel. So and so like that means that also Chris has a copy of that data. What is it that stops Chris from stealing my car? And the answer must be Brad knows some information Chris does not know. How did Brad obtain that information? That's the most important question in this entire conversation.
So the problem that we are trying to solve is to make sure that whatever information, the provisioning information that you are trying to transmit to Brad, that information is transmitted securely. So if your original channel was not secure enough, that's a second problem that can be solved by second factors by the vertical. That's that. So for instance, in your case,
you can't just like I want you to describe how the problem is actually solved, not push it off to the vertical. Even if eventually we decide to solve it, like I'd like to do demonstrates there's a solution. So like what is like how do I give Brad whatever secret he has that distinguishes him from Chris? Like what is the channel I use for that?
And so that would be adding that restriction that the first channel is super secure, right? I mean, define security properties, and then basically the problem is solved in that sense. So the restriction,
no, I don't think so. I guess I'm still not following you. Like we take this URL, whatever it is, with information in your draft or my draft, and we post it on the internet. And now, what is it that lets Brad take my car and not Chris? What information does Brad have that Chris does not have? And how did he obtain it?
So it is same in that sense between your draft and ours, right? I mean, I don't see how it is.
Yeah, I agree. Draft. I agree. I'm trying to talk about the threat model, not about the designs.
Right, but that we believe is out of scope for this the Tigress channel that we are trying to ask for. I mean, I think maybe that's the confusion.
Described that wasn't, you were trying to put that in scope of what you're solving here. If you're not, that's useful to say, but we need to understand the properties of this.
I'm gonna step back now because I think other people do.
Sorry, yeah, it broke down a little, so I couldn't hear the whole.
Okay, well, I'll after the meeting, I'll put together a summary and send it out, and we'll continue the conversation on mailing list. We'll move on. We have a few other people in the queue. Tommy.
Yeah, thank you. Yes, I agree with the points Ekker's making. This does seem quite important. I wonder if, again, a useful way to think of this would be to not think of saying, okay, we have the second factor that we use in cases where the connection is insecure initially, but instead, for the core protocol, the equivalent of what Ekker was talking about, say that thing must have a secure channel. Like if you're going to share this thing that starts with it, you have to be secure. That's where the secret is. That's where the URI template of where you're going to rendezvous is, all that. And that means that for cases, like you say, okay, we trust iMessage as a secure channel. Maybe we trust WhatsApp. I don't know. You have other end-to-end secured messaging channels, or you're doing a direct transfer. That in those cases, you're like, great, I can just use the core protocol directly. And then we have this separate problem for SMS or other insecure channels. I post this on the web somewhere. And that feels like that's a separate extra bespoke mechanism where you're really just posting, hey, I'd like to share this car key with you. And now we need to bootstrap a secure channel between us and somehow, identify, do you think this person on the other end is really this person? I don't know. But like, if we're going to decompose, like a piece like what Ekker had of the actual secure transfer mechanism, you have like an application level description of what the messages are, and then you have this other bootstrapping step that allows you to go from insecure postings to allowing you to have that secure communication. And maybe we just say these are three separate problems. Let's not try to muddle them up into one protocol, but we just treat them separately.
Right, and that's, I guess, the point, right? I mean, we are trying to create a secure communication channel for that provisioning information, which should work irrespective of the security properties of the first out-of-band channel. That is the point, I guess, we are trying to make. So just because I use WhatsApp or whatever other secure channel deemed secure, shouldn't mean that I should use a less secure transfer protocol, right? I mean that. So we are trying to define a transfer channel that is secure enough, irrespective of what is the first out-of-band message channel, if that makes sense.
Just to add to that, I think we had a set of requirements when we first tried to solve the problem that we presented, and obviously introducing a secure channel end-to-end encryption between Alice and Bob would be solving slightly different problem because it's very hard to achieve without establishing without changing information about identities of Alice and Bob, either through like MPLS or any available end-to-end encryption protocols, Signal, WhatsApp, iMessage. So if we want to bring that aspect into Tigris, then it would be solving different problem, in my opinion.
So, Prachi, should we get
Yeah.
with questions or maybe in the next couple of slides quickly?
Yeah. So Aaron, Brad, Dimitri, just okay. Aaron, Brad, we'll hold off the questions. Yogesh, if you want to quickly go over the slides, keep it short, maybe 2 minutes,
Yep.
and then we'll answer some
Absolutely.
questions and then close off. Yeah.
The next slide, please. So we have defined this quick sequence diagram to describe how this user interaction flow would work, where user initiator only has to act once, and then the sort of magic happens under the hood, which is that secure channel that Tigris will provide. And same from the recipient side, you accept it once, just one interaction, and then the magic happens underneath. Next slide, please. So for us, the idea was that that channel is defined, we call it as relay server. And I think, Dimitri, you want to take over? I can continue.
Yes, of course. Thank you, Yogesh. Again, our original proposed was based on the intermediary server, based on HTTP methods such as get, post, delete, like REST. And all the complexity was distributed between client and server, and the relay server had to deal with mechanism of linking to clients, sender and receiver, to the mailbox, similar to the mechanism proposed in Eckers with bread draft. Basically, these are the cookies, just called differently, sent in the request headers. And once there is a unique receiver, the mailbox will be linked to that receiver, and the sender obviously has the right to write to the mailbox. And these guarantees uninterrupted data exchange between the relay server will not accept any calls from anyone who doesn't know that cookie or mailbox claim. And thus we establish uninterrupted data exchange between just two clients. And that was the original idea. And since our original requirement was not to collect any identities from sender and receiver, we built our proposal based around this requirement. Can we move on, please? So, and what is important? We try to implement. Roger, can you move on to slide 8, please? The provisioning information. So I'll skip the slide for the sake of time. So what we try to present here is a seamless user experience. So all the pieces about the preview information stored in the mailbox, that basically serves one purpose, so that both users can exchange the data using convenient mechanisms, iMessage, SMS, emails, and they have a chance to see what they accept before they start the actual secure exchange. And we use push notification mechanism so that the clients on the devices would know when to go and fetch the data without doing long calling, which preserves power and network traffic probably. And the URL itself carries some information of the type of credential being delivered. So the vertical, as we mentioned in the beginning, represents the particular data set of credential, whether it's a key to your car, whether it's a key to a home or a hotel. So all of these is embedded into our proposal. And move on, please. And the last thing is that we already have deployments, both for relay server and the clients. Yep. That concludes basically what I wanted to present.
Okay, thank you, Dimitri, Yogesh. We are right on time, so I don't think we'll be able to take more questions. Aaron, Brad, if you can post your questions on the mailing list, that would be wonderful. The chairs are going to put together a summary and we'll send out the meeting minutes. And I think we need to talk about getting back to the basics and clarifying maybe the requirements at this point. I'll let everybody go, but we'll continue the conversation on the mailing list. I do want to quickly bring up, there is this idea floating of making a design team probably. So we'll bring that idea to the mailing list as well, because we can clearly see there is some interest and people have different opinions around things. So we'll try to bring together all the brains in one room and brainstorm and come up with the proper solution. So with that, I want to say thank you to everybody. Let's get back to mailing list, keep the momentum going. We have a ton of stuff to do before 118. And Leaf, do you have anything to add before we Okay, looks like Leaf is having trouble with his audio. All right, with that, thank you, everyone. We are out of time.